All right, we're looking at ellipses. Now, an ellipse is very oval-like. Now, an ellipse is defined as the locus of points in a plane such that the sum of the distance from two fixed points called foci, it's plural of focus, is constant. Now, this is a pretty good way of actually thinking about what that definition means. Say you have like two points, two fixed points, those are our foci, all right? And say you take a string and you attach it between these two. Now it could be loose or whatever, but then you take that string and you take your finger, you take a pencil and you pull it as tight as you can, and you start drawing around those 2 points. Now, in the middle, you're going to be able to pull it pretty tight, and you're going to get to that point, and then as you go further away from one foci, you make your way around. You can only go so far away from both of these. You're maintaining the same sum of difference. So like the distance between these two plus the distance between these two is going to be the same as when you get to this point on the ellipse. The sum of that distance plus this distance will continue to be the same. That's what this means. Draw it out if you need that visualization a little bit better. So there's a lot of little pieces to an ellipse. All right, clearly we have a center. Okay, we have a point that is the center of our ellipse. Now, notice because an ellipse is not a circle, all right, don't get it confused, it's not a circle, okay? It is wider in one direction than it is the other. So we have what we call a major axis, that is the longer, the part that's wider on our ellipse, and we have a minor axis. Okay, minor axis is smaller than the major axis. These are perpendicular to each other. They meet in the center. From the center, it's the same distance to each vertex. The vertices are at the endpoints of our major axis. The co-vertices are at the ends of our minor axis. And once again, the foci are very important. Every single point on our ellipse, if we were to measure the distance from one foci and measure the distance to the other foci and add those two distances together, that sum is always the same for every single point on our ellipse. That's the definition of an ellipse. That's how they're created. So, a lot of little parts. Now we do have some standard forms for our equations. They do look kind of terrifying just looking at them here. Notice that it is x minus h squared over a squared plus y minus k squared over b squared equals 1. And this is very similar to when it is taller than wider. Okay? So we basically either have a horizontal major axis, where the major axis is horizontal, or we have a vertical major axis. Now the only difference here is where our a squared is and our b squared. Okay? First of all, a must always be greater than b. A must always be greater than b. So if you notice that the bigger number is in the denominator underneath the x minus h squared, the term with x, if you notice the bigger number is in the denominator of this term, well that means, okay, because a is affecting the major axis, that means a was affecting the x values. X values are left and right. It is spreading it out from left to right. So if the bigger number is in the denominator of the term with x, that means we have a horizontal major axis. But if the a term, if a squared, if the denominator is bigger underneath the y, that means it's affecting the y values. That means we're going to have a vertical major axis. So that should kind of help us to sort between these two. Now, other than that, it's pretty similar, but just remember, if it's a horizontal major axis, that means the horizontal major axis contains the vertices, not the co-vertices, and the major axis contains the foci, and that's how all of this works out here. The center is HK for both. The foci are very similar. Notice that we have to have this C value here, and C is not present up there in our formula. We obtain C down here at the bottom. But C is a constant. In this case, C is affecting the X values. The Y value stays the same. And that's because our foci are located on our major axis, and our major axis is horizontal on this one. Over here, since our major axis is vertical, the C value is affecting the Y values to get our foci. Well, the vertices are the endpoints of our major axis. And so since they're part of the major axis, again, the Y value is staying the same as the center, but notice the A value affects the major axis, so it is plus and minus the values for A. Over here, it's still the A value that affects the major axis, but because it's vertical, it's affecting the Y values of our center point. Very similar to the co-vertices, but B is affecting the co-vertices because B is affecting the minor axis. Major axis Y equals, well, the major axis here is horizontal, so it's Y equals the Y coordinate, opposite over here. The minor axis in this case is vertical, so it's X equals H. Over here, the minor axis is horizontal, so it's Y equals K. Now to obtain C, these two things mean the same thing. C squared equals A squared minus B squared. Okay, so we got A and B, we can find C. So that was a lot of information. Take notes on if you need to. Now we'll go look at some problems.